In this video, we're going to do a little bit of data munging. That is, we've got some data that we don't know exactly what it looks like, and we're going to try and figure it out by doing some work in Python. So I'm going to be not writing a program and executing it, but writing lines one at a time in the Python shell and seeing what happens to explore what's in the data. The only thing I know is that somebody's given me a pickle file. Now you can either just watch this video or play along with me. The file is called munging.pkl, and I've attached it to the page up in Canvas that has this video on it. So you can do the work yourself and try and see what's going on. The only thing I know is it's got a pickle in it, so I want to import the pickle package. Then I want to open the file. I've copied the file into the same directory that I'm running my Python shell from, so I can open it by saying something like input file equals open, quote, munging.pickle, comma, quote, RB. Remember why we put the RB in there? For read binary. If you don't put the B, if you just put an R, or if you leave this out altogether, the default is just the string R, which means read it for input in human readable form. A pickle is not human readable, it's binary. Okay, my file is open now. You remember I can use the load function from the pickle package to load objects. Now, I didn't tell you how many objects I've pickled into this file. So let's just start seeing what happens. Object 1 equals pickle.load from the input file. That worked. There must be at least one pickle in there. Object 2 equals pickle.load from the input file. That worked. There must be at least two pickles. Object 3 equals pickle.load from the input file. That worked. There must be at least three pickles. Object 4 equals pickle.load from the input file. Oh, that one didn't work. What happened? It says EOF error, end of file error, ran out of input. This file must only have 3 pickles in it. Okay, so I've got an object 1, an object 2, an object 3, and an object 4, and I don't need the file anymore. So I'm going to say input file.close so that I'm not tying up that file any longer. If I try and use object 4, notice what happens. It says object 4 isn't defined. That's because the statement that would have created object 4 failed because I ran out of input. So I've got object 1, object 2, and object 3. I don't know what's in them. Maybe I'll print them out. Let's do print object 1, object 2, object 3. Oh, lots of stuff. Okay, I've obviously got a list because there's a square bracket with another square bracket, so I've got a list of lists, and then another list, and there's some curly braces, and then there's some curly braces with brackets, and lots of quotes. It's really hard to tell what's going on, and this is with 3 objects. Suppose I gave you tens of thousands of them. Probably need to work on this a little bit more systematically. Let's see, of those 3 objects, let's just see what the type of object 1 is. Object 1 was a list. I wonder how many elements are in the list. Length of object 1. 4. 4 elements in object 1. Let's see what the element square bracket 0 is. The first element in object 1 looks like a name and an email address. Let's see if the next one, object 1 square bracket 1, a name and an email list. Object 1 square bracket 2, a name and an email list. Object 1 square bracket 3, a name and an email address. Okay, I think I figured out what object 1 is. Object 1 seems to be the students and email addresses that we used in one of our earlier lesson videos to show you some complicated data structures. Well, I wonder what object 2 was. Object 1 up here has the Anya artichoke, Baruch banana, Consuelo cookie, Divya. Okay, so starting here, oh, I've got a square bracket of a curly brace of a string. Too complicated. What is the type of object 2? It's a list. How many elements are in object 2? I've got 4 elements in object 2. Let's just look at one of them. Type. Not type. Let's just do object 2 square bracket 0. It's got some stuff in it. What's the type of object 2 square bracket 0? It's a dictionary. Now, it's a fairly simple dictionary. It's just got a name and an email. But you can imagine I might have a dictionary that had tens or 20s or hundreds of different keys in it. So is there a way on something that was more complicated than this that I could just see what are the keys in here? Sure. How about for key in object 2 square bracket 0? So I can do for key in any dictionary, and object 2 square bracket 0 was a dictionary. Let's print the key. And it says my 2 keys are name and email. So I could do something like object 2 square bracket name. And then, oh, it says, nope, the list indices must be integers, not strings. Oh, because it's not object 2 name. It's object 2 square bracket 0. That's the dictionary. And it has a name. It says, oh yeah, the name of that person is Ms. French. I wonder, object 2 had 4 elements in it. The first one had a name and an email. I wonder if the second, the third, and the fourth also have a name and an email. Let's try that out. Let's do object 2 square bracket 3 name. It had one. The name was Joe Cool. Object 2 square bracket 3 email. It had an email address. Okay, object 2 seems to be the teachers from our example in an earlier video. Wonder what's going on with object 3. Let's see. Let's do the type of object 3. It is a list. Length of object 3. There's only 2 things in it. Let's do the type of object 3 element 0. That's a dictionary. So I've got a list of dictionaries. What is that dictionary? Oh my, this one looks a little bit more complicated. Object 3 square bracket 0 is a dictionary, and that dictionary has a section in it, a course, and I've got a dictionary of dictionaries. That's hard to parse. Let's see what's going on. Let's just see what are all the keys in object 3 square bracket 0. For key in object 3 square bracket 0, print key. Okay, I've got section, course, room, teacher, and period. So object 3 square bracket 0. Oh, and I'm tired of typing that. Let's give myself an easier name. Let's call it X equals object 3 square bracket 0. Now, X, I've got to type X correctly, X section. X section is just 1. The section number is 1. Okay? X course. Oh, that was complicated. What is the type of X course? It's a dictionary. I wonder what all the keys are in it. It looks like there's a description and a name. Let's just verify that. For key in X course, print key. Description and a name. Okay. So now, instead of using that X, how would I get to this blah, blah, blah? It's a description within the course element, within X, which is the 0th element of object 3. So let's see if I can just print out blah, blah, blah. Object 3, square bracket 0. Okay. Square bracket section. Square bracket description. That wasn't it. Why not? An int object is not subscriptable. What was not subscriptable? Oh, because the section isn't the one that has a description. It isn't the section that has a description, it's the course. So let's do object 3, 0, course, and then description. Can I print blah, blah, blah? Yeah, I did. Now, I've got a really complicated set of data here, but not a lot of data. I only had 3 pickles in here, and each of the pickles only had a couple or 3 or 4 elements in it. And even if they were complicated elements like a dictionary, they only had 4 or 5 keys to them. Sometimes our data is going to be an awful lot more complicated. And you don't want to do something like object 1 equals, and object 2 equals, and object 3 equals, and object 4 equals if there's going to be something that has 30,000 objects. So let's see, what can we do? Let's open up that file again. I've already closed it, so I've got to open it. So I'm going to put input file equals open munging.pickle for read binary. Now I'm going to go through and try and read each one until I get an end of file error. So that means I want to go through a loop, and I don't know how many times I need to go through it. So I'm going to try and go through it an infinite number of times, knowing that eventually I'll get an end of file and it'll stop. So how do I go through something an infinite number of times? While true, that one's always going to be evaluate to true, so it'll always execute. Object equals pickle.load input file. And it comes back and it says, oh, I ran out of input. Okay, good. Well, let's look at the objects that I got before I didn't save them. Everywhere here, I just said rewrite whatever object was into from pickle.load, rewrite object. Well, maybe they're in object. Okay, well, that just has the last one that I read in, not the first one or the second one. So, what can I do? Let's close that munging file again. We'll do input file.close. I'm going to open it up once more. Don't know if you've learned this trick yet. If I go up and find a line that I like, to put the cursor there, hit enter, it repeats it. Okay, I've opened this up, and now I'm going to have something called a list of all objects, and I'm going to make that equal to an empty list. I'm going to do my while loop again, while true, and instead of saying object equals pickle.load input file, I'm going to say list of all objects dot append. What am I going to append to it? Pickle.load input file. Now, I get this end of file ran out of input, but let's see what's in list of all objects. That one has a length of 3, just like we expected. There were 3 pickles, so I ran through the loop 3 times. Now, in a future lesson, we're going to learn how to avoid getting an end-of-file error like this using the try statement, and try and accept, and we'll trap this end-of-file error and do what we want, which is to close the input file. Okay, close is not defined. Yeah, I did it wrong. It's input file dot close. That'll work. All right, so you've learned a few things in this lesson. You've learned you can explore data by playing around in the Python shell. You've learned that, yes, your instructor makes syntax errors, but it doesn't bother him because he can just try again. And you've learned how to maybe explore what the data is that you get in a pickle using type or length or print statements or a loop that prints out all the keys in a dictionary. Okay, go forth and do good things. Happy programming.